يعطيكم العافية. عماد العقيل من الكويت. السؤال حقيقة اللي طرح الدكتور بخصوص التقنية وكيف تتحول التقنية. هناك تخوف عن السوشيال relationship between the human being. هذا التخوف اللي موجود أنا يعني أتساءل فقط. شكرا.
Dr. Kaku, should I repeat the question? Or?
Yes, technology is a sword. And it depends on who controls the sword. One side of the sword can cut against disease, poverty, illness. The other side of the sword can cut against people. So what's important is that the people control the sword. In other words, we want to have inputs, democratic inputs from many people. Now, some people say that technology also creates rich and poor. For example, about 10 years ago, people talked about the digital divide. People thought that only rich people would have laptops, tablets, computers, and poor people would have pencils and paper. So there would be a digital divide. Wrong. That didn't factor in Moore's law, the fact that computers get cheaper every year, and who uses the computer today? Children. Children are one of the driving forces of computer technology. And so people didn't realize that mass production, better shipping, containerization, and Moore's law will drive down the cost of these technologies. And so technology, in some sense, is a leveler of inequality rather than a creator of inequality. Now, at first, things are expensive. That's a given. But with time, because of mass production, Moore's law, prices are dropping. So nobody talks about the digital divide anymore because we know that even poor families are being wired up.
طيب نخلي التحية للجميع إن شاء الله في آخر الحوار. بما أن هذا العلاقة بمورس لو، اسمحوا لي السؤال اللي جاني هنا بالعربي وبعدين بيترجم. ما الأساس الذي يعتمد عليه Moore's law? What are the bases that Moore's law is built on? I mean, how did it come to be like that? I mean,
right. Moore's law simply says that computer power doubles every 18 months, and that has changed everything. And the reason for that is simple physics. For example, if you want to make a t-shirt, how do you make a t-shirt? You get, first of all, a template, and then you spray paint. You spray paint through the template, and that's how you make the t-shirts that you buy at the store. In the same way, instead of using paint, we use ultraviolet radiation. Ultraviolet radiation goes through a template, and that template then allows you to very fine-tune the ultraviolet radiation on silicon. So instead of a t-shirt, we use silicon. Instead of paint, we use ultraviolet radiation. So this works great until you hit the wavelength of ultraviolet radiation. At that point, there is a limit, and that limit we are gradually reaching now. So Moore's law cannot last forever. Some people say that if Moore's law were to keep on going, machines will be smarter than humans very soon. I don't think so. Because of the fact that ultraviolet radiation only has a wavelength that puts a limit on how small you can make a transistor. So eventually we have to abandon the t-shirt model and go to more advanced forms like molecular transistors or quantum computers or atomic computers. But anyway, that's why Moore's law works, because we use light, radiation of light, to make t-shirts or templates of smaller and smaller size.
طيب سؤال من عند thank you very much. سؤال من عند السيدات. إذا ما في سؤال بسرعة تفضلي.
This question is by Abdurrahman Al-Qadi. He's a student in King Saud University. The question is talking about digitalization process and automation. Don't you think that they will make our world more materialistic than it already is? And how is it going to be at that age? Also, how to overcome this drawback. Thank you.
What was that question?
So the question is the coping with the technology and the advancement and the increase
Will
of
make
rate of
humans
automation.
more inferior. It could make humans more inferior.
Humans
Yes.
become more inferior to machine and the world become materialistic.
Oh, I mean, once machines replace many human jobs?
Well,
Yes.
even before that, once they keep advancing, they replace human jobs, they make things faster.
Okay, well, the jobs that are being replaced now are repetitive jobs, jobs that are done repeatedly over and over again. Jobs that require pattern recognition. Computers are very bad at that. Computers can see, they don't understand what they are seeing. Computers can hear quite well. They don't understand what they are hearing. So jobs that are non-repetitive but blue-collar will survive. In other words, gardeners, policemen, construction workers, sanitation workers. These jobs cannot be replaced by robots easily because they involve pattern recognition. The other kind of job that is very difficult to replace involve common sense. We know that water is wet. We know that mothers are older than their daughters. We know that string can pull, strings cannot push. We know that sticks can push, sticks cannot pull. But how did you know that? How did you know that water is wet? How did you know that? Because you've touched water, you've seen string, you've seen mothers. Mothers are older than their daughters. Robots have not. Robots do not have common sense. And so far, even our most powerful robots do not have the common sense of a 5-year-old child. And so these are the two reasons why robots are not going to take over the earth anytime soon, because they don't look very well, they cannot recognize what they are looking at very well, and because there are so many rules of common sense that children understand, but robots do not. Therefore, the jobs of the future will involve intellectual capital. For example, think of a stockbroker. Stockbrokers today no longer sell stock. Now that sounds stupid. Stockbrokers sell stock. No, stockbrokers no longer sell stock. You buy stocks on the computer. So what do stockbrokers sell? They sell intellectual capital. That is, experience, know-how, imagination, the inside story, innovation. That's what stockbrokers sell now. So if you want a job being a middleman, the only way you will survive is if you add intellectual capital to your job. Otherwise, your job will go out the window. But it does mean that jobs involving science, jobs involving art will survive because robots are not creative. Robots cannot create science. Robots cannot create a joke. They cannot write a novel. And so the jobs that involve intellectual capital will gradually replace jobs involving commodity capital.
Thank you very much. I think we're up for the last question. On the back here. تفضل. سريع سريع.
Okay, my question is for Professor Kaku. My question is, you say in the future there might be time travel. How is that going to be while Dr. Albert Einstein said that the only way to go back in time is to be faster than light? Well, actually, he said it's impossible for an object to be as fast as light.
Yeah, there are several ways to go in time. If you use Einstein's special theory of relativity, you cannot go backwards in time. But in 1915, Einstein came out with a more powerful theory, general relativity, and in general relativity, time travel is possible. Einstein himself realized that if the universe, for example, were rotating, then in a rotating universe, if you go around the universe, you come back before you left. So in other words, you go backwards in time simply by going in a circle. Since that time, we have found hundreds of solutions of Einstein's equations which allow for time travel. So what's the catch? The catch is if you calculate the energy necessary to go backwards in time, it is comparable to a black hole. So you would have to have the power of a star before you could go backwards in time in a time machine. So we physicists do think that a time machine might be possible, but the energy necessary to create it is fantastic. It's the energy of a star. Then the question is, what happens if you go backwards in time, meet your parents before you're born, and your mother falls in love with you? If your mother falls in love with you before you're born, then you cannot exist. How can you exist if your teenage mother just fell in love with you? The answer is the quantum theory. At that point, the universe splits in half. In one timeline, your mother did not marry your father. In one timeline, your mother fell in love with you. However, your timeline does not change. The river of time splits in half. Therefore, there are no paradoxes in time travel stories. If your mother fell in love with you before you were born, that's not really your mother. Looks like your mother, talks like your mother, had the same genes as your mother, but it's your mother in a different timeline. So we use the quantum theory to resolve paradoxes in time travel.
I am very happy to travel to Boston and not travel in time. I'm very happy where I am right now. So thank you on behalf of the audience and the organizers. It was a delight to coordinate this session, and please help me thank Dr. Kaku and Mr. Tarabzuni with a great loud applause for their great presentation. Thank you.